Okay, this is just a quick video to give to anyone who was missing from school on Monday or Tuesday of March 8th and 9th. All right, we're going to be talking about vectors, and remember that the reason why we need to do vectors is because they are the beginnings of our problems in physics, and so we need to know how to do these, or else we won't be able to do the problems. Remember, we looked at this video the first day of school for Unit 4, where we had vector, and vectors are arrows that have magnitude and direction. All right, I went over the grade book. So if your score from the test for Unit 3B is not to your liking, remember first to bring your work to me so that I can see if I can give you partial credit. If you're not happy, we can do corrections, and if you're still not happy, you come talk to me and I'll figure out another way for us to raise that grade. All right. So first of all, when we do vectors, we pretend like we're following directions, like we're going from one place to another. So in this first slide, we're going to learn the difference between distance and displacement. Distance is how far you walk. So in this example, we have a barn, and we're going to go follow the directions from the barn to the house, which are go north 2 kilometers, turn right, go left, or go east 2 kilometers, you get to the house. Right? If you were to follow those directions and actually walk that distance, you would travel a total of 4 kilometers. And that's the distance that you traveled. That's how far you went, and you actually walked. But displacement is a different idea. Displacement is how far did you get from start to finish? And that is represented by just a straight arrow from one to the other. Okay, we talked about a lot of different things that use distance and displacement. One of them is when you get in the, when you Google something and you say, how far is this away? They might give you some number like 4.6 miles. But then when you get the directions from Google, it says it's 7 miles. And that's because when they give you the distance away, they're giving you the displacement, like if you could actually fly there. But when they actually map it out, well, then they give you the distance. So displacement is this arrow. And how would we find the arrow? Well, a lot of times the easiest way to do it is just to simply look at this as a right triangle. And since this is a side, and this is a side, and this is the hypotenuse, we use the Pythagorean theorem, a squared plus b squared equals c squared. All right, so to find this displacement vector's length in this problem, it would just be 2 squared plus 2 squared equals c squared, and so c ends up being the square root of 8, or 2.82. All right, so the displacement would be less. And we can see that in the picture. It's 2.82 kilometers. All right, that's the difference between displacement and distance, and those two concepts will be tested for sure on a quiz and then again on the test. So you need to know the difference between those two. All right, so here's a couple more examples. The dotted line is the distance that you walk. The red line would be the displacement, right? Because it's just a straight line between the two. Here, this little cat thing, right? The distance is that whole dotted line. The displacement is just the red line. And the one that we like to test a lot is, let's say you're doing a race around the football field, the track, and you did this race, right? The distance around the football field on the inside of the track is 400 meters. But the displacement, we start from the same spot that we finish, the displacement would be 0, right? Because we've gone nowhere between the start and the finish. We ended up in the same spot, and so we end up at 0. So that's the extreme, and that also is likely to be tested. All right, draw a vector representing the force. So remember, that was the first thing. What's the difference between distance and displacement? The second thing we learned was, how do we draw vectors? We went through a big discussion about direction, but magnitude is easy. If we want to draw a vector that's 10 newtons long, well, it's pretty simple. We draw a vector and we mark it as 10 newtons. But if we had to then draw one that was 20 newtons long, well, remember that we then draw that arrow twice as long because the vector length represents its magnitude, how big it is. So very simple. Magnitude is simple. If it's a small number, we'll draw a small arrow. If it's a bigger number, draw a bigger number. Okay, and make sure that there might even be some sort of correlation between them. So if this one's 10, then the 20 Newton one would be twice as long. All right. We then went through a whole discussion about direction. Direction is much more difficult than magnitude because what a vector can be in any direction we decide. And how do we describe that? And so we went through all the different ways that they tried to describe it with the compass. The compass is a little bit wrong because there's got so many different possibilities. There was this 0 through 360 that they use in aviation. We could use a grid, but we came down to a very simple way that they use very often, and that is we mark this as 0, and then we go around this set of compasses to 360. So up here would be 90, over here would be 180, over here would be 270, and then over here, 0 would also be 360. All right, and so when we were to, if we were to give you a whole bunch of angles to draw, 30, 95, 210, and 290, there's only one possible answer with this way of naming our angles. The 30-degree one, right, would just be straight up this way to 30. I guess that's maybe 40, but anyway, it's 30. That would be that direction. 95 would be right there, just a little bit off of 90. 210, well, this is 180, so plus 30 more would be this way. And 290 would be this way. So just so you know, I mean, they're not perfect. I didn't draw them perfectly, but that's the whole idea, right? That way, there's only one way to describe an angle by its number, a number between 0 and 360. It's likely we will not be testing that very much. Okay. All right, then that was the number 2. So 1, what's the difference between distance and displacement? Number 2, magnitude and direction in vectors. And number 3, how do we add vectors? And so what we did was we said, remember what there was a time when you didn't know what 2 plus 5 was. You had to actually check it. So you maybe had to count on your fingers. You know that now that's 7. But at one point, you probably didn't believe it, or you probably walked into class and you're like, oh yeah, 5 and 2 and that makes 7. Well, today we're learning what does vector A plus vector B look like? And here's an example. So what is A plus B? And just like maybe back in kindergarten when you didn't know what 2 plus 5 was, you probably don't know what A plus B is. But A plus B equals this vector right here. It's the displacement vector that we just learned about. It's the vector from where we start to where we finish. A plus B equals what we call the resultant, or R. Okay, A plus B equals R. And hopefully by the end of these next couple weeks, you'll start to believe that A plus B is equal to R. You're certainly going to practice it, and we're certainly going to need to use it. Why? Well, because for a long time, we're going to find a vector that might look like this, and we're going to need to figure out what's its x component and what's its y component. Why would we want to know? Well, because if we can figure out what its x component is, we can do all our x and y x calculations, our speed calculations, left and right. And if we know its y component, we can do all of its free fall stuff up and down. And we can combine those two ideas to figure out what happens when we shoot things up or down, or we work in 2 dimensions. All right. Bottom line is, how do we add vectors? We add vectors with this idea called tip to tail addition. So the first one they told us to do is C plus F. So C is right here. C is a 5 square vector. Take C, and then we're going to add F to it. F is a 1, 2, 3, 4 down and 2 across. That's like that. And so C plus F looks like that. What does C plus F equal? Well, it's the displacement vector from where we started to where we finished. And so it goes all the way down to there. okay? C plus F equals that orange one right there. All right, we did some X and Y components and figured out the resultant. I don't know if you need to do that. We'll get to it if we do, but we just need to be able to continue with this tip to tail addition. So we're going to do one more example on this video. What's A plus E? Well, A is 3 to the right, and E is then down. So A is this way, 3, and then E is like that. And you can see, right, I take the tip of the one and I add the tail to the next. That's why we call it tip to tail addition. And the resultant, or what does A plus E equal? It equals this one right here. That's the R right there. That's the R right here. So C plus F equals what we call the resultant. Okay, A plus E equals this resultant right here. And what you should notice about these is that there's not a circle of arrows. So don't put, if you end up with circles of arrows, you're going to get this wrong. It's this, follow the directions down to here, and then draw the resultant, which is from the beginning to the end. All right, so what were you guys doing? Well, what you needed to do is then go to the Google Classroom. And once you were in the Google Classroom, there'd be a unit 4, and there's only one thing, physics in 2 dimensions. There's a March 8th/9th adding vectors, and you'll go to this thing called block copy of homework, open it up, and you'll get some vector addition stuff. The way that we do these problems is we grab the blue arrow that's on top of the black arrow. So A plus B, we would drag this blue arrow over here. All right, and I can't really see that very well, but I hope that that's kind of on the right path there. And then we'd add B to it. So we got to add B to it. So I'm going to drag A down a little bit and add B to that one. So you can see that I'm doing tip to tail addition. Right, here's A plus B, and then we're dragging this red thing over. We're putting the tail on where we started. We'll grab this blue button and drag the red over there. So that's what it looks like. A plus B equals the red, and you'll do that for homework. All right, there's a couple more things to do. There's directions in there. So there's a page right here where you're going to drag these red arrows to the right. You're going to put a circle on one of these 3 letters. And then over here, we're going to be adding vectors. We're going to be looking for their components. And I'll just help you out real quick. The first one, I'll let you guys do, but the second one, don't worry about these arrows, these like orange and blue arrows. Just look at the components. And so I'll do the first 2 as an example. Here's the purple one right here, right? It starts down here at 0, 0, goes up to here. How many X's did it travel between where it started and finished? Well, it traveled -4 in the X direction. And how many Y's did it go between here and here? Well, it traveled +4. So this one, the numbers would be -4 and 4. All right, the second one, is there any X's here? Did they move in the X direction at all, this purple arrow? The answer is no. I'm going to drag this yellow thing off of here. Right? The answer is no. So there's 0 X component. It didn't go X to the left or the right, and it has a -4 in the Y direction. That's what you need to do, and I will see you guys at the end of the week.